Hello everyone, how are you today? My name is Piotr Pasich and this is a Mentor Monday where we're going to focus on the blockchain and Bitcoin technology. Last week I left you with a little homework that we're going to resolve during this short recording, during this short video. We installed a Bitcoin node that we switched to the testnet mode, and today we're going to actually use that because it's really important to communicate with that. And the homework was to create a sample code where we're going to create a way of communication with the Bitcoin node we installed last week and grabbed an information about them and gather an information about the last block, and we've included transaction in it. So we're going to do that right now, and I have already created a simple directory. Here we go. This is an example from our last week. I created the my node configuration, and I just created the project, which is empty right now. We're going to work on that. The very first thing that we need to do is to open my node with the bitcore to make the bitcore node, the Bitcoin client, able to synchronize successfully with the blockchain information, because we will need that. And on the other tab I will enter the project and init the npm package because we're going to use it. I'm going to call it Bitcore Mentor Monday. I think it will be cool to share it with you on the GitHub. I will see if it is possible. Entry point, the index, test command, we don't need it. This is only for our purpose. And what we're going to do right now is to grab a package from the GitHub library. Where is it? GitHub, which is available from the BitPay, Bitcoin library. As you can see, this library will deliver as a functionality, will be responsible for communication with the Bitcoin node, but it allows us only to write to the node, to manage our wallet and the addresses, and for the for gathering information from the node it will require one more library to install, which will deliver all of the endpoints that we used last week with the insights from exactly here. So what we're going to do is to install the Bitcore library. And the second library I mentioned is the Bitcore Explorer. I hope that will work. Explorers. Okay, here we go. So right now we have two installed libraries, and we're going to open new file, index.js. I'm not going to write a really good looking code right now because we will be focused only on this particular example. Maybe in the future we will polish a little bit the code that we're going to write, because I will put everything into one file and just run the node from the command line. But of course it is done only for the purpose of this specific example or the exercise. So what we're going to need at this place is the Explorer object from the library we already installed, Bitcoin Explorer, and we need to create a new inside object that will be responsible for communicating with our API, which is sorry, my fault. New Explorer address, maybe call it as it is with the S at the variant. Inside it delivers an interface for the inside, which allows us to put the address of the inside, but it ends with the API, and also allows us to introduce ourselves with the, I don't know, testnet. Let's call it a testnet. We need a block hash of the latest block. Let's check what it is, block hash. And now we're ready to gather information about this block. So we take the inside object and use the request get method that we accepts an address to the API endpoint, which is the block plus our block hash, and the callback function. Of course, it's possible to shorten the annotation or use the promise, but for this specific example I would like to stick to the callbacks, because everybody knows the callbacks, don't they? And the response, it returns us the callback with the two arguments: the error if somebody went wrong, like the communication with the with our node, or the response where every piece of information will be added to our response that we every piece of information about the block right now. Response. Okay, here we go. So we're going to see what is inside the response, and I really hope that this piece of the code will be working. Of course it's not working, because why not? Unexpected identifier. But VAT. That's everything what we like. So what we got is every piece of the information that is included into the response block, but what is really important for us is the body section, which is encoded right now. So what we're going to do is to take the body section, and this is encoded with the JSON format. We are able to add the slash at the very end, and don't use it here. That would be really cool. So the body is encoded in the JSON format. So we're going to decode this, pass the JSON format, and see what is inside when we call the block method. Inside we can find a couple of things like the hash number, which should be the same like we put there. We have the size, which we really don't care, because it's the size in the bits that are included into the blocks. Mostly it's like 1 to 2 megabits for the mainnet, and for the testnet it's really a random number depending on the number of transactions included into the block. The height is the number of the block, which is increased during every mining process. This block is 1292029, and the previous one will be decreased by 1. So we are able to gather any information about the block from this height number, not from the hash, because obviously you're not going to know what the last hash of the block was, but you will know what's the next high is, and I'm going to show you how to do this. Version is something we don't care about, like the Merkle root. We really do care about the transactions array, where we can find the hash IDs of all included transactions to the block, and we need to decode that. We need to ask the blockchain, our blockchain node, for every single transaction which is included, because we're going to need any information about the sender address or the receiver address that are participating into the transaction. Another stuff which is important for us is the previous block hash, because it points to the previous hash if you would like to check if everything is correct and is mine chain, which is true, because you might receive the orphaned blocks, but for our purpose we will just omit those conditions and be focused only on gathering information from the transactions. So another part will be go through the body JSON and get the list of the transactions, put it to the for each function, because this is an array, we will have transaction there, particular transaction hash, and we will need another kind of this function inside, but sorry for the semicolon, not the block but the transaction here, tx plus transaction hash response, and we do exactly the same thing with the transaction. So console log JSON parse response. We'll do something like that because from time to time it doesn't work if it just threw an error because it cannot find the transaction. Not everything needs to be synchronized with our network. So if it will show an error, we'll know about that. And let's check if everything is correct. Of course not, because why not? Why should it be? Unexpected token O in position. Which line is it? Okay, not every transaction that is included has got a properly included JSON file, but as you can see, we have a couple of information about the transaction here. So we've got the transaction ID, which should match whatever we have in the blockchain. We have the in transactions. This is an array with the transaction with the addresses that send the transactions to the receiver, and vout is an information about the receivers, the addresses of the receivers. The first one address will be dedicated for the actual receiver, and the second address will be dedicated for the newly generated address of the sender, because if you are a sender and you will send some amount of the bitcoins that is quietly lower than the amount of the bitcoins that you have on a specific address, it will create a transaction that will send some amount of the bitcoins to one address and create another address assigned to your account with the rest of the bitcoins that you created. So we're going to be focused on the VIN and the VOUT right now, because that's something what is really important for us. Let's check the VIN. Okay, we got this. So we have the script seek, which is encoded transaction. We are able to get the information from that, and the sender address. Let's check that this way, because this is still an array, and when you're parsing any information from the blockchain, you will use a lot the for each function or the reducers, because everything is put into the arrays function. Here we get our transaction. And here we got the addresses who sent in, the transaction from some transactions from our account. We of course are able to add the ID or the hash of the transaction. Let's check what is inside. Okay, here we go. TX ID. So we're going to have TX ID plus, sorry for the so this is a list of the senders split it into a couple of into the transactions, and now we can focus on the receivers, because we're going to look out for the receiver here. Transaction, Node.js. So the receiver have a couple of more information, and receivers, there might be a couple of receivers. So we have an object of the transaction. We have the script pub key. Let's copy that. It has a different design, different structure than the v-in array. So we need to have the script pub key and addresses. Okay, so that's all of our receivers here, and from time to time you do not have the receiver. This means that the transaction was mined. Or you can have a couple of receivers, which is quite fine too, but we do not have this kind of the example right now. But if in the example, in the case when you would have more than one receiver, 2, 3, or 4, you will have here a couple of addresses in the array, and probably one of those addresses might be your address, and that's how you recognize if the address is dedicated for your payment. Because let's see, if we would have this address saved into our database, we should be able to find it in the database and catch if the users actually send the money. We don't care about the sender address, we really care about the receiver address, so the address that we take from the v-out transaction. So there is one last thing that I would like to talk with you. This is this hash, because as you can see, this is a really long hash, and you really wouldn't be able to guess this hash, but every block has its own high. So you can take some example high and save this as latest passed block height, like this. We'll increase that after every run of the our code. So what we need to do is to take a block number inside, request get block index. This particular thing API method will help us with that. We'll pass there our number, and we do behave as in every previous example, response. Okay, we're going here, JSON parse. Let's check. We have the block hash, copy, and now we're going to do the same piece, to execute the same piece of the code like right below, but we're going to remove that. Right now we're going to receive an information from other block okay, here we are. Any information from any transaction included into this particular block. Whatever what we need to do in the next step is just increase by 1 and execute that once again. Another list of the block, and another one, and another one. So that's basically what we would like to do for you, and that's the exact way how you can gather any information about the block, lastly mined block or any block you would like to see from the blockchain with included transactions. And what we really care about are the transactions with the vout, which are specific in the specific receivers, because when somebody wants to pay with the bitcoins on your website, you will generate a new address for him. This address will be assigned to your wallet and you will be in possession of this address. So the buyer will send his bitcoins to your address, and you will recognize this buyer and will be able to recognize also the order or any kind of the other payment within this specific address. So this is the most important thing when you generate new address for the order in your e-commerce shop, in example. You need to save that to the database because you will be not able to recognize to which transaction or to which order you have received your money. And that's it. And for the next week we will take care about this process, this specific process. We will create a fully working transaction lifecycle, starting from generating this specific address, unique address for the user who's going to pay with the Bitcoin on your website. We'll generate his the address. We will gather information if he already paid for this, if he's already sent the transaction, and gather information from the block. So we will basically implement the payment method with the Bitcoin, and that's something what I would like to leave you for the homework. So see you next week, and I hope you enjoyed this video. Goodbye.